To part 2B of the notes. Alright, I know the last video cut off somewhere in problem 3. I'm not exactly sure where, so we're going to go ahead and we're just going to start problem 3 from the beginning. Okay, let's hear a big yay. Alright, so here's what we're going to do. It says, problem 3 says two concentric circles have radii of 4 and 8. Okay, so let's go ahead and let's draw in the radii. Okay. Well, first of all, before we do that, let's actually look at what exactly a concentric circle is. Okay, so we can go ahead and find this on our vocab up here. There's the vocab for concentric circle. It's two circles that have the same center point. So, in other words, it's really a circle within a circle. Okay, so if I want to draw the radii of the big circle, okay, I could go ahead and draw that there. Okay, and I know that that is going to be 8. So the radii of my bigger circle is 8. And then I know the radii of my smaller circle, okay, is 4. Let's go ahead and draw that in. Now, it says find to the nearest hundredth the length of a chord. So notice that CD is both a chord of the larger circle, because it connects 2 points on the circle, and it's also a point of tangency, or it's also a tangent to the smaller circle because it intersects at 1 point, okay, and that's point O. Now, go back up to our theorem list here. One theorem, it says, is this theorem right here, that's what we're going to use. It says that if a radius is drawn to the point of tangency, okay, so in this case, or in this problem, that's point O, right? I think that's a Q. I can't tell. Yeah, we're going to go with Q, or else we have 2 O's. So anyway, that's the point in between D and C. That's a point of tangency. So if a radius is drawn to the point of tangency, then the radius and the tangent are perpendicular. Okay, so that means that we have a right angle right here. Okay. So it wants me to find the length of this entire chord. Okay, I don't know the length of the entire chord, but I am going to call half of that chord x. Okay, now, based on some of the theorems we've talked about, since this radius right here, okay, since it is perpendicular to the chord, we know that it also bisects the chord. Alright, so that means that CO, or CQ, and DQ are both congruent. So I'm going to use the Pythagorean theorem here and say that x squared plus 4 squared, see how we have a right triangle right here? I'm going to say that x squared plus 4 squared is equal to 8 squared, and now I can go ahead and solve for x, okay, which would be half of my chord. So that's going to give me x squared plus 16 is equal to 64, which is x squared is equal to 48, okay, which means that x is equal to square root of 48. Alright? Now, again, that's only x. The problem says find the entire chord. So CD would be equal to 2 times root 48, and then the problem wants it to the nearest hundredth, which means that it's going to be about, I believe that rounds to about 13.86. Okay. Alright, and that's all for session 2B, okay? I know we're going to do problems 4 and 5 in class. Alright, so if you have any questions, please feel free to ask.